All right, we're going to be finding the GCF, the greatest common factor. I'm going to show you more than one way to do it. Okay. The long way to do it is the way you learned possibly in elementary school, where you listed out all of the factors, and then circled the greatest one that they had in common. That's fine, but you definitely don't want to do that when you have large numbers. So there's a different way to do this. I'm going to show you 3 ways. That was one way. I don't ever want to see you do that way. Please don't do that way. You're most likely to forget a number when you're factoring it. So I prefer one of these ways instead. You prime factor these numbers and you make sure you put them in order 2, 3, 5, 7. And you stack them 2, 3, 5, 7, just like that. So 16, remember you would have to do a factor tree if you don't know it, is 2 to the 4th power. 24 is 2 cubed, 8 times 3. Okay? So common base, lowest exponent, you circle it. Common base, nope, they don't have a common base of 3, so you don't circle anything. So your GCF is 8, 2 cubed, which is equal to 8. That's your GCF. This is one way I prefer. This other way is pretty easy too. It's called cake. This is your cake method. In a lot of years, this is the chosen favorite method for people. This is prime factorization method. So this is prime factoring method. First method, I just want you to forget existed. So cake is, I'm building my first layer cake right here. And I say, what is the biggest number that goes into 16 and 24? 8? 8 goes into 16 twice. 8 goes into 24 3. Can you factor 2 and 3 any further? No, nothing goes into them except for 1. So you're done. The number right here on the outside of your cake, right here, that's your GCF. Done. See how easy that was? Or let's say you didn't know what the biggest number was. So let's say you started off with these 2 numbers right here and you said, okay, let's try that again. So I have 16 and 24 and I start to build my cake. Let's just say, for the sake that you don't know your times tables very well. Well, you need to get to know them better, so work harder on that. But let's say the biggest number you can think of that goes into 16 and 24 is 2. 2 goes into 16, 8. 2 goes into 24, 12. And then you look at this and go, oh, but wait a minute. Something goes into those, so I'm going to cake it again. What goes into 8 and 12? Oh, well, 2 does. 2 goes into 8, 4. And 2 goes into 8 of 12, 6. Does anything go into 4 and 6? Oh, yeah, 2 does. So do it again. 2 goes into 4 twice. 2 goes into 6 3 times. Does anything go into 2 and 3? Nope. Okay, cross those out. You're done. What's 2 times 2 times 2? 8. So you don't need to know the exact number that goes into them, the biggest one. You could, this is called a triple layer cake. Okay? It's not that hard. Yeah. Your book will show you a completely different way. You choose your method that works best for you. Really, it's about getting the correct answer. So you have 18 and you have 30. Start building your cake. What's the number that you can think of that goes into 18 and 30? 6. 6 goes into 18 how many times? 6 goes into 30 how many times? Can anything go into 3 and 5? Nope. Done with that. There's your GCF. easy. 28 and 35. I'm pretty sure most of you can just look at that and know GCF is 7, right? Because then you get 4, 5, done. GCF, done. They make it complicated. Okay. When you have 3 numbers, you sometimes have to be careful because you can continue to cake it even if one of them is done. So in this case, I don't think we're going to have that problem, but in your homework, you might have that problem. So you say, what goes into 12, 48, and 72? Can you think of a number that goes into all of those? You want to just start with 6? 6 goes into 12 twice. 6 goes into 48, 8. 6 goes into 72, 7 times. Got that? Now, can you continue on, or is that your GCF and you're done? I'm showing you their process that they went through it. Okay, so see how the answer is 12? So let me go back and show you what I meant by sometimes you have to continue caking right here. Because although 7 can't be caked, 2 and 8 can be caked to be 1 and 4. Now 1, 4, and 7 can't be caked anymore. So here's your GCF right there is 12. So keep that in mind when you're doing more than 2. That if you have the numbers come down here and you still have at least 2 that can be caked, cake them. Even if they're not next to each other. Okay, you try 24 and 32. That's your answer, and that's your answer for B. Parents donated 150 chocolate chip cookies and 120 molasses cookies for a school bake sale. We generally will have the conversation of what is a molasses cookie and why would they want them, but that's okay. Some people like molasses. So really all you're doing is caking 150 and 120 to find out what is the largest number of plates possible. Largest is the key word that you're looking for the GCF. Now the easy thing to do is to cross out the zeros and cake 15 and 12 and then add the 0 back on. So 30 possible plates. Then the question is, well, how many chocolate chips and molasses cookies will be put on each plate? Well, if you have 150 chocolate chip cookies and 30 plates, don't you just need to know how many 30s are in 150 and how many 30s are in 120? So we do need 5 chocolate chip cookies per plate and 4 molasses. And this is the same kind of question. See if you can answer it. First, find the GCF of 96 and 72. And then find out how many can be put in each basket. Okay, GCFing monomials. Don't make this hard. So we could cake it with the exponents in it, or you can just remember the rule. As long as they're in common, you pick the lowest exponent. So I have x cubed y squared and xy squared. Common base, lowest exponent. Common base, they're the same exponent, so just pick one. Now all you got to do is cake 18 and 42. And figure out what goes into them. So your answer would be 6xy squared. I'm going to show you how to cake it now with the exponents in it. So you have 18x cubed y squared and 42xy squared. Okay. So when you're caking it, you cake the number out, and then you take out the maximum number of x's that you can take out without going above the lowest one. So I have x cubed and x, so I can only take out an x. I have y squared and y squared, so I can take out 2 y squareds. So what am I left with? I'm left with a 3. I took out 1 x, so I'm only left with 2 x's. I took out all the y's. took out a 6 here. I took out one x with no x left, and I took out the y squared. There you go, and you're done. You don't need these. You just need that. So do it again. So when you're looking at this, you know that you could take out an m, and you know that you can take out an n squared. Of 32 and 80, you can take out an 8, right? So then I have 32 m n to the 4th, 80 m cubed n squared. Maybe I could take more out than 8. So 8 goes into 32 4 times. I took out the m and I took out 2 n's, so I'm left with n squared. 8 goes into there 10 times. I took out 1 m, so I'm left with only 2. I took out all the n squared. But 4 and 10 isn't done. I wanted to double layer it for you. 2 works. So I have 2n squared, 5m squared. Now I'm done. 8 times 2 is 16m n squared. The good thing is if I'm going too fast, you can always rewind or pause. Factoring a binomial. So when you factor a binomial, do you remember doing the distributive property? So if I had 2 times the quantity of x plus 7, I said to you for every one thing inside, you make 2 lines like this. 2 gets distributed to the x, 2 gets distributed to the 7, okay? This is reversing. So I've already distributed and gotten my answer. Now I need to reverse it. So what was it before is really what I need to do. Like that. You can cake this. Let me show you. You probably, by the time we're done, you might be in the mood to bake a cake. So think of it as 2 monomials, just like we were just doing. 3 on the outside, right? Because 3 can go into this and this. No variables on the outside. What are you left with? An x and a 4. This is on the outside, this is inside. So it's 3 times the quantity of x plus 4. That's factoring the binomial. Do it again. So again, I have 4x plus 20. 2 goes into it. Do you think we should go higher than 2? Should we choose 4? We're left with x plus 5. There you go. 4 times the quantity of x plus 5. If I distribute it, I get 4x plus 20. That's what I started with there. So again, this on the outside is the GCF. On the inside is what you're left with when you take the GCF out of the problem. Yay! Good luck.